Hello everyone, welcome to today's session. In this lab we are going to walk through setting up two essential components for building high availability and scalability web applications on AWS, the application load balancer and auto scaling group. Now you can see this architecture diagram. So we got our load balancer over here and our auto scaling group over here, and we got a VPC, two different subnets. Now the load balancer, as the name suggests, whenever let's just create a scenario over here. We got a web application in our system, EC2 machines, EC2 machine. Okay, so they are the same web application but in a different location, different subnets. So let's say there are thousands of users, and one server can only handle 500 users. So we need to divide the traffic. So load balancer does that. We need to divide the traffic. So whenever a user 1 make a request, it sends the server in the server 1, and user 2 gets sent to server 2. So ultimately we are dividing the load for each server. Now auto scaling group, let's say we not only have 1,000 requests, now we got like 10,000 of requests. So instead of just 2 servers, we might need 5 more servers, but we might not need that server all the time. Let's say at night time we only need 2 servers. At daytime, at peak hours, we might need more than 2 servers, 5 servers. So in that case, auto scaling works. We use auto scaling to automatically scale up or scale down the instances. So number of instances are currently 2. So if we have more requests, then we can auto scale it up to multiple user instances. So that's how auto scaling group works. Now let's try to set it up in our actual environment. Go to AWS console, go to VPC, create a new VPC. I'm just gonna name it custom VPC for now. IP address, you can choose any network address. I'm going to choose /16 for this. Tenancy is default. Let's create a VPC. Let's go to subnet now, and we need to create 2 subnets to test it out. We can create multiple subnets, more than 2, but for the lab purpose we can just test it out with the 2 subnets, but 2 subnets are must. Inside our custom VPC, let's just create subnet 1. So make sure it's public subnet. I'm just going to name it public subnet 1. Availability zone, let's say number A. I'm gonna give IP address of 0.1.0/24. So we already talked about it. 16 is a larger network and 24 is a smaller network. So generally 24 means it's dividing the section of 16 into a smaller group. Add a new subnet, and yeah, so we're just gonna name it public subnet 2. Let's put it on number B, and 10.0.2.0/24. 24. Okay, now we have created our subnets. We created the network, we created the subnets. Now let's see. The next thing is we're gonna create internet gateway. So internet gateway is a router. Let's create it to access internet. Obviously, I'm gonna say custom internet gateway IZ. We need to attach it to our own VPC. So action attach to VPC, custom VPC attach the internet gateway. Next is route table. If you follow the documentation over here. Now route table, we already talked about it in our 3-tier architecture lab. So it actually directs the flow of route. Let me just create it one and I'll show you. Okay, so I'm just gonna name it my public route table, custom VPC, and create route table. We need to assign subnets. So we got 2 subnet in this VPC. So we are just gonna assign both of the subnet. So what does route means? Just add something. If you want to go to any other websites, we're gonna go through internet gateway. Save. Okay, so this is the route that we created. Okay, and these are the subnets that are inside the route table. So anything inside this subnet, for example our EC2 machine, if they want to access anything else except this, if they want to access anything else, then the traffic goes to internet gateway. So anything else means it can go to internet, it can go to any other public subnets or different subnets within AWS, but if it goes to 10.0.0.16, so it will be locally routed. So that's how the internet gateway works. Okay, so after the internet gateway, we also set the route. Now let's create an EC2 instance for testing purpose. EC2 go to launch template. So I will be creating via launch template. It's much easier. Let's just say custom template. I'm gonna give version 1 for the naming. For our operating system AMI, I'm going to choose Amazon Linux for this one. This is free tier obviously. For instance, I'm going to go with T2 Micro, again a free tier. If you need a bigger one, you can select the bigger instance type. Key pair, so we already know about it, right? In order to get SSH into the server, we need the key pair. So I have already created one, the same one from TTR Architecture Lab, so I'm just going to select it. If you don't have any, you can just create from there. Subnet, so okay, for now I'm not going to select any subnet, I will just let it be default. Security group, so let's just create a new security group. I'm just going to add it as our custom security group for our lab auto scaling group and application load balancer. This is just a name. I'm gonna allow port number 80 and 22 open. So this is our description. We need to select our VPC, custom VPC. Let's add a rule. So first rule would be our HTTP protocol, that is port number 80 for everything from everywhere, and the second would be our SSH protocol from everywhere for right now. But in real practice, we need to minimize this. We need to only make sure only our IP can SSH into the server. So then after that we got storage volume. We don't need to make any change on this. Advanced details. Now at the bottom we know about user data. So user data is something that instance run when it starts. So we got a big user data for this one. Copy this. I will explain it in a while. So the user data about this is, let's just go through line by line. Okay, we got update command, so it updates the system. We got nginx installation command, so this command installs the nginx. We got start and enable, so this automatically starts the nginx server. There are a few things over here: token, instance ID, private IP, public IP. Okay, so the token is something that we need in order to access this kind of instance, this kind of IDs from the instance itself. So what this is doing is, this is generating a token from its current IP address, and then with that token it is trying to get the instance ID, private IP and public IP of this particular instance. So wherever this code is run, it tries to get instance ID, private ID, IP and public IP of that particular instance the code is being run on. And at last it creates the index.html file, or it updates the index.html file within user share index, user share nginx HTML. So this file, and this file, it changes the file to HTML body, instance ID being instance ID as variable from here, and private IP as from here, and same as public IP from here. Okay, so if we just open this website, then we should be able to see this kind of instruction in our website. So that's all about the user data. Let me just create a launch template for this. Okay, after launch template we need, let's see, anything else. So yeah, we need to create at least 2 to 3 EC2 instance from this so that we can test it out. So I'll just create a 2. Let's go to our launch template and create 2 EC2 instance from this. Just gonna create action launch instance from template. So make sure you make some changes over here. So only change that you need to make is the subnet part. One should be in public subnet. Actually, you can put both of them in the public subnet 1. It doesn't matter. We're gonna delete it, but for the sake of this tutorial, I'll just put it in 2 different subnets. Okay. This is the first instance. Let me just create a new one. Launch. Where is it? So for the second one, we're just going to create 1 instance. Okay, so if you go to EC2 instances, so you can see, let me just clear this out from the status. Okay, so you can see we got 1 instance running and the second instance almost initializing. Okay, so these 2 are the instances that we just created. Okay, now after we create an instance, we need to create a load balancer. Let's go to the load balancer section, and then we create a load balancer over here. We need to create an application load balancer because we are hosting an web app. Just gonna name it. So we got it over here. My application load balancer. For network, we're gonna select custom VPC, and we need to select. So where do we want this load balancer to be? So we need the load balancer in both of. We can just select one, but or we can keep the load balancer in both of the availability zone, and it is much better this way. Scale effectively. For security group, let's just create 1 security group. We're just gonna go over here. This should be our custom load balance security group. We're gonna allow port number 80 for this one. This is on VPC custom one inbound, should be port number 80. Yeah, there you go. And create a security group. So why did we create that? So as you can see, in order to get access to our web server, we are getting it through load balancer, right? So at least load balancer port number 80 should be open as well. So we can hit port number 80 on load balancer, and the load balancer redirects that port to these websites or the instances. Okay, we got our load balancer. Sorry, we got our security group over here. Let's go to load balancer, refresh this, and we should have our custom load balancer security group. To remove the default one, just select this one. Target group. So we need to create a target group. Create a target group. All of these are in our documentation as well. So we got our target group section. Just gonna copy this name. Yeah, we need to redirect to instances. Target group should be named. We are targeting on port number 80 for that particular instance, and then we are gonna select custom VPC. Then next, nothing else to change, and we got 2 instances in that particular VPC, right? We just created those. Include this, create target group. So this will take some time. Once it is healthy, we can test it out. So in the meantime, we got our target group. Let's just refresh it, select the target group. We don't need to make any other changes, just create a load balancer. Okay, our load balancer is being created. We need this particular area card or DNS name, so just copy it, paste it in our website, and press enter. So this might take some time. It takes time to create a load balancer, so just wait for a while before it loads. As you can see, the status is still provisioning. Now let's continue with the lab for now. Okay, now the thing is we need to set up an auto scaling group. So till this part, what we did right now is we created VPC, we create subnets, we create load balancer, we create EC2 instances, and we create web server within the EC2 instances with user group, user data. Now we should be able to access the website. So if our load balancer is completely running, then we can access the website directly. But as we talk about auto scaling group, if our network or if our traffic is more than 2 servers, let's say these 2 servers can only handle 1000 traffic, right? So if we need 10,000 traffics, then what? Then in that case we need to increase the server number. So auto scaling group works on that. Let's set up the auto scaling group and make it so that it can increase the number depending upon what is demanded. So this still takes time. Let's go to our auto scaling group and create one. I'm just gonna name it custom auto scaling group. The template is the one that we created in our EC2 section, so the same template, because each time whenever we create a EC2 instance, it should be the same, right? So if we create a third instance over here, it should also solve the web application that is same as these two. So we created a launch template, and that launch template will use same web application all over. So that's why launch template are needed over here. And press next. We need a VPC, so it is obviously custom VPC availability zone. So where do you want this to be created? So availability zone, we can select multiples. If there are 3, we can select 3 availability zones as well. But for currently we got subnet in 2 availability zone, and that's why we can only select 2. So whenever we need a new server, it will select one of these 2 subnets and create a server within it. So that's what we select like this. If we just select public subnet 1, then whenever we need a server, it will only create on the public subnet, like over here, maybe a second one inside this, third one inside this, fourth one inside this, not in this section. But if this availability zone or this subnet goes down, then all of the server are lost, right? So we need to create high availability and high redundancy. So due to a high availability requirement, we need to select multiple subnets. So if it creates 2 subnets, or if it creates 2 instances, then it will create one on subnet 1, and it will create second on subnet 2. So that's the way we make it highly available. Let's check our load balancer again. So load balancer is there. We got our target group up and running. Okay, it says unhealthy. Let me just debug it. Before that, let me just copy the else name, paste it over here. Okay, I'll just pause the video to debug the session. Okay, I found the issue. So the issue is like this doesn't have a public IP address. We forgot to set it up. So let's go to our let's go to our launch template. It should be inside the launch template. Create the launch template and modify the template, and just within the network section, advanced network, we can have it over here. Okay, so we are supposed to enable this section. Okay, I forgot to do it. We already got security group. We are just enable this part. Now go to advanced network and enable auto assigning IP address. So this will be our new template. So I'm just gonna name it version 2 over here, and create a template over here with the last template. So you remember we just selected a template in our auto scaling group as well, right? So if you go back to auto scaling group and if we go to previous section, so we got versions, version 2 is there. So just select the version 2 now, because if you select the version 1, it will create an instance without an IP address again. So select the version 2. Next. So before that, let's just create 2 new instances with a new template. So I'll go to my EC2 instances, running state, and just delete the 2 instances that we created. I'm just going to terminate this, and I go to my launch template and I will create new instances, but make sure you select version 2 over here. This is a good debugging session as well. So yeah, select subnet 1. Okay, I'm just gonna create these 2 instances in the same subnet. It doesn't matter right now. Okay, launch it. So this is created 2 instances. If you go over here and refresh the page, we should be able to see. Just give it a few moments. Refresh it. Okay, so you can see one is being initialized. Just keep refreshing. Okay, 2 of them are there. Now the thing is, we got our target group, right? And target group, we selected 2 instances, and both of them we already deleted it. So let's select new 2 instances in our target group. Register target, and we're gonna select the 2 instances that we just created, include, and register. Now hopefully this works now. Let's just go to our instances and check it out manually. So now we got our public IP address. Let's try to open it. Make sure you only put HTTP over here. Just give it for okay. So it's working now. Now you can see the current IP address that I put over here, 52.56. So public IP address is this, and private is 10.0.1.9. You do remember we put 1 over here, right, for our public IP address. So the naming convention is a little bit different, because this public means the one that exposed to the internet, and this is the IP address that is of subnet. Make sure that. So after this is being loaded, let me just click on my DNS over here, and let me just put it over here again and run it. Now you can see our load balancer is serving our website. So this is our website, right? Let me just refresh it once. So now you can see we are getting 2 different IP address if we just refresh the page, right? So what does this means is, if you go to this architecture, so whenever I hit the load balancer, it is redirecting me to one of these 2 servers, right? So it is redirecting me first on this server, and if I hit reload page, it will now redirect me to this server. So what does this means? Our load balancer is working completely fine now. So it means if there are thousands of users, then 500 users would be redirected to this section, and another 500 would be redirected to this section. So we are balancing the load. So that's how this works. If you just refresh it, now you can see I'm being redirected to different servers. Okay, so our load balancer is working fine. Let's go and set up our auto scaling group now. Go to this is the section for auto scaling group. Select custom VPC availability zone. As you say, we want new servers to be created in both of the subnets, not only the one. And so this is about how do we create. So the first one says it will check the healthy availability zone, and it will just put it over there. So if both are healthy, then it will just choose one of these 2 randomly, or maybe. And then load balancer, yeah, we already have a load balancer, so attached to an existing load balancer, and we have a target group, right? So target group, click on this. So what happens right now is, whenever the auto scaling group creates a new instance, then it will set that auto scaling then it will set it in a target group of load balancer. So let's say a new instance is created over here with auto scaling group, then that particular instance is automatically connected to the load balancer. So it is being done by target group like this with these settings. We then need to set up PPC lattice. We then need to set up this one. If we need to check health, here we can just enable this one. So health check grace period, so try to reduce it. For normally 300 seconds is good for production level, but for our testing purpose we cannot wait for 5 minutes to know the changes, right? So let's just put it like 5 seconds over here, and next. So now this is the one main important part, like desired capacity and scaling capacities. So how many servers do we need to be running at a time, right? So with the example that we got, I want at least 2 web servers to be running at one time, or maybe I can say like at least 3 web servers to be running at this time, and I want my minimum to be at least 2, so you cannot go below 2, and I want my maximum to be 5. So why this maximum? Let's say you got like more than 20,000 requests, and that will cost heavy on your server as well, right? But you don't want like thousands of servers to be running. You might want to limit the amount of server. It's okay, like some of the user cannot access your website, but you want to limit your cost as well. If it starts to run like thousands of servers, 2,000 of servers, and if someone is trying to attack your website, and our auto scaling group creates 1,000 different servers for that DDoS attack, then it's gonna cost you a lot. So for that reason, we need to specify the max desired capacity. So desired capacity, like how many should be running right now? So this is the number 3. Let's go. Do you want to enable scale protection? So we don't want to do this right now. This is not a purpose. And these are some of the policy. If you just go through this, so it tells about what to do when you start it. When you start a new instance, how do you check? So how do you define, like you need 5 servers, not 4 servers, you need 3 servers, not 2 servers. So these are the things we can define over here. Okay, probably over here. Now then click on next. Notification, we don't need it. So the notification is something like, let's say if we are running 10 servers, then we want to be notified to us like you are now running 10 servers. So we will get email address, we will get email from this or anything else to notify us. Click on next, click on next. Okay, everything is done. Click on create auto scaling group. So this create an auto scaling group. Now you need to remember one thing. In our instances, if you go to instances, we only got 2 servers running, right? This one is not related to our lab, so we only got 2 servers running. But what we did over here, in our auto scaling group, we said we need 3 servers. Minimum is 2, but what we desire is 3. So generally what auto scaling gonna do is like it's gonna scan our servers, and it will know like we only have 2 servers and we need 3. So what it does, it creates the 3 servers over here. So if you go to this, refresh it, and you can see over here it got 3 servers. So just make sure like these 2 servers are not considered by auto scaling group. It will create a new 3 servers and try to close this automatically. Let's check it out as well. Let's just wait for this server to spin. Just give it some time. Okay, at the meantime, what I will show you is, so we are running this server over here, right? We are testing it out. Let's just keep refreshing this part as well. So you see, we are getting different IP address now. So those servers are already up and running. So I got 61, I got 9, I got even 2. So one of the server is on our subnet 2, subnet B. So we got IP address with number 2 as well. If I just keep refreshing it, but if I go to the server section now and try to refresh it, so this might take some time. Let me just put it out. Or what you can do is, once this is up and running, you can go to your auto-scaling group and refresh this as well. So you can see it will show the activity of what's to be done, right? So let me just show you one thing. I'll just delete these 2 servers that we created at the beginning, and I'll delete 2 more servers from auto-scaling group as well. Let me just instance and delete all of this. So if you refresh the page, it shows those 4 are being shut down. And if you go to our auto-scaling group and refresh this part, it will take some time to notify, around 5 seconds, or a little bit more than that. Just give it some time. Maybe it might take some time to reflect over here, but if you still go to your EC2 machine and refresh it, so you see these 4 are terminated, right? Now if you keep refreshing it, you will see something different. Just refresh it once again. So as you can see, there is one server that is pending right now. What this means is, this server is being automatically created. I didn't create it, right? I just refresh the page and just wait a second. Just give it some time. So this is this has started to run now. Let me just click on the pending one, refresh it, all status. Just refresh it. So it takes a little bit time to for this to happen. Just refresh it over here. So you can see it detects like one of the EC2 is down, so it creates the new one, right? Now once it detects other EC2 are also down, then it will start to create other EC2s as well. Just give it some time. It will automatically detect if the EC2 is running or not. But this might take some time, like few minutes. Let's just wait for the second one. Okay, let me just refresh it completely. So this one is created on subnet number 2. So as you can see, the new EC2 instance now starts with pending status, right? So if you go and check it over here, so it detects the termination of EC2 and it launches the new one. So why is it launching? Because we need 3 desired capacity. So it will try to fulfill this desired capacity over here. because we only got one running over here, and it starts 2 more, so the total capacity now is 1, 2 and 3. So it will now stop creating the EC2 instance. But if I delete all 3 of them, then it will again create 3 new EC2 instances. Now how do I completely stop this EC2 instance? Like if I want to stop the EC2 instance, then I should select all these 3 and delete it, right? But if I do that, then our auto-scaling group will know it, and it will again create 3 instances. But we will think like we have already deleted this. We have already removed the EC2 instance, and we should not be paying any money to AWS. But our auto-scaling group will create 3 more. So in order to stop this, we need to actually completely delete the auto-scaling group itself. So we can delete the auto-scaling group, and then that's how we can stop the creation of this. I should have actually okay, we can still do it, I guess. Yeah, so yeah, that's the lab. I hope you guys enjoy it. Thank you.